Assalamualaikum warahmatullahi wabarakatuh. Let me introduce myself. My name is Dhini Minarti with a student ID 422311022. In this video, I will talk through my midterm project title, which is image classification with a machine learning paper. The goal of the project is to build the complete machine learning people that can recalls and clarification handwriting letter from the EMNIST dataset using HOG feature extraction and support feature machine classification. Okay, the first one is as Bible overline. Before driving the code, let me give you a quick overline on the entry pipeline. The pipeline consists of six cents. The first one, load the raw data set from the CSV file, and then second, perform a balance and sampling, and the third, exit OG feature from the HME image, and then the fourth, normalize the feature using a standard scaler, and then fifth, train and tune the SFEM classifier using a great search. And then the last is that we evaluated the model perform using the standard metrics. Okay, this is how I make it import libraries. This is how to import libraries code. Okay, the NumPy and the pandas for data manipulations, and then mm, matplotlib and then seaborn for data visualization, and then from sketch image e to import the HOG function for picture extraction, and then from sklearn, which is import SVGs from the SVM classification, and then also the last import standard scalar to normalize HOG the picture. And then when I'm going to run this program, this is how to output make library build successfully. And then we're going to move the dataset preparations. Okay, the first about the dataset. The dataset I'm using the EMNIST Letters Dataset and standard from the Exxon and NIST as a quality of handwriting character image. And then the training GZVL5 uh 80 88.800 row and 785 columns. The first column is the cost level with a value from 1 until 26 preferential leader auto C, and then the remaining 284 column represents the pixel value of the 28 by 28 gray cycle image. And then this is a point of the sampling loop in the code. And then when I'm going to running, that is a make a sample like this, for the output because loop the torque is other unique class label randomly pick for 100 sample from the class, and the collects from the audience after collecting all indicate. Observers are dumped randomly to mix the classifiers together. This is how output the shows, and then this is how to make a recipe and orientation fix. as per the level from the pixel data and replace the pixel value from the flat factor of 784 value into the 28 by 28 imaginary matrix. There's an important detail, and this image a stone is transformed comparison to what the expect. So I'm applying the memory transfer function to correct the orientation, make a little later upper rate, and then this is a sample X image 200 2600 and then the sample Y and the same. And then this is how to visualizations can see the sample image for the each of the 26 letter display in the A in the 4 by 7 grid. The image look correct after the orientation fix. This is how the shown. And this later dataset sample. One image per class A until Z. And then this is train. This is how train the dataset into the 80% for the training and 20% for testing using the Strathfield spleen and Strathfield meanings at the class dispersion in the displays it both the training and the test set. This is the output. And then we're going to move to HOG feature extraction. What is HOG? HOG is a standard for histogram of the orientation gradient. It is a feature extraction technique commonly using the computer vision from the shape and the texture explains. Okay, the first is a computer image gradient, and then is a define the main image to small cell and with the histogram, and then finally is a grown neighbor and cell into the bulk, and normally that the histogram to make the feature robot. And then this is the code for the output number of the feature per image 1726 and standard applied. And then this is a code for sample classes. For sample classes, for the normal chassis, them using the standard discolor, and this transforms each feature to have a zero mean and unit variance. And then the HOG for HOG visual, you can see comparison between the original later image and their HOG made. The bright pattern in the HOG map shown the dominant gradient direct and which is outline the shape and stroke of the H letter. You can see that HOG clearly capture in the structure of the letter like A, B, H, and other. This is shown. And then going to classification as VM plus screen search. Create search automatically finding the best parliamentary core combination. The parliament in this case, we have a three parliamenter. The first one is Cornell, and then the second is C, and then the last is a gamma. The best ratio kernel equal RBF and C equal 10 gamma equal scale for CV accuracy 60.62%. And there's the param grade. This is how this is shown that this program is shown, and then the running grade search 60 combination equal 5-fold, and then flipping 5 folds for each of 11 12 candidates, totally 65. The best parliament C for 10, comma for scale and kernel for RBF with the best accuracy 0.606 x082. And then this is a great search HATMAP. HATMAP has shown the cross of validation accuracy from different combination of C, gamma, and using the RBF kernel, darker rate meaning the high accuracy and currently set the C for 10 with the gamma scale and perform the best. This is the shown when we're going to run the program. This is make the shows. This is auto scale gamma, C for regularity, and great set for RBF kernel, CV accuracy versus C and gamma. And then this is for training performs evaluation of the best SVF model and the training data at how get 100 accuracy. This is a completed X test for SVM. The model have a memories the training data really matters how it is programmed and using the test data, which we'll see the evaluation section. This is the output when you going to running this program is does make a training accuracy for 1.0000, which is same with the 100%. The value of 1.0 mean the model fit reflected to training data expected for SPM. And then this is going to the evaluation. This is evaluation for performance metric. The first one we have accuracy, which is for proportional of a kernel prediction of the all prediction. And then the second precision is out of all prediction for class X, how many are actual class X. And then the third is recall of all actual class example, how many were correct the predicate. And then the last F1 score, which is his harmony means of the prevision and the recall. And then this is a cross validation for a 5-fold certificate. For the false, this is how the note on the LOOCV, the third level one of the crossing validation on the 2006 example will I recall the training the SVM the 2006 times 1 hour's place a 5-fold certificate CV and with challenge accept academic alternative is a provider the reliable estimate of generation performed with the 4 more experienced computation time while still flowing in the spirit on the course of validation requirement. This is a sample program the cost for class of validation. the five full severe ratio, the accuracy approximately 80% with the precision recall and the F1 score all the in the similar range shown in the model in the core the accuracy and 26 plus when this is the how shown. So accuracy, precision, recall, and the F1 score. This is a program when we going to know how the value for the full accuracy, precision, recall, and F1. And then this is the program for a test set evaluation on equal 20%. This is when we're going to run the test accuracy based on the from the above code, which is the test accuracy, test precision, recall, and the F1 score with the same. This is how the per class report. This is a preparation, recall, F1, and support for the A until key, and then accuracy. We have for accuracy, we have the F1 score 0.82, which support 5020 with the macro AGV with the same value, and then with the AGV with the same value with macro AGV. And then since confusion matrix. This is confusion matrix. This is point the confusion matrix hat map. The confusion matrix shown in detail how well the model's clarification is layered. The diagonal cell is shown in darkness blue reflects the correct precision of diagonal cell is shown Mr. clarification. We can notice that the some visual similar letter that some are confused with each other. For example, layer like A and G or U and V. This is understandable, giving the visual similarity on handwriting version of the letter. A and G. This is a very similar. And then for the performance summary, this is the bar chart summary of for metric accord the training set, the fightful cross validation on the task set, the consistency between the CV result and the task result competency confirm that the model is well calibration and generated properly. This is a performance metrics. This is accuracy, precision, recall, and then F1 score. Okay, the last is conclusion, final configuration. This is for the component. We have a data set, HOG orientation, HOG pixel, per cell per block, HOG feature cone, SVM kernel, SVMC, SVM gamma, and then evaluation. For the winner result, for the test set to 20%, this value is matrix for accuracy have a score 81.54%, and with a precision 82.49%, with a recall 81.54%, and then F1 score with the 81.53%. For the distillation, the HOG plus SVM equivalent achieves approximately 81.5% accuracy on the 26 plus handwritten letter classification tags. The custom HOG parameter, which is a finer cell at point X point, more orientation bin at 12, capture model details edge information compared to the default, which is contributing to improve the performance. The RBF kernel with the C410 provide a good balance between the margin maximum and train error tolerance. The gap between the training accuracy until 100% and the test accuracy, we got the value 81.5% is expected. It's a normal generational behavior in the SVCM classification on the high dimension, the feature and space. Overall, the HOG plus SVM blend proved to be the effective and efficient approach for handwriting letter classification without using any deep learning technique. I think that's all for my explain for my midterm project. Well, I'm so apologize if any mistake for explain on the project. I thought is this all for my presentation. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.